Hi guys, welcome back to another e-learning video. This video will be over probability, specifically theoretical probability. Please make sure you have a pencil, paper, and a calculator in front of you. If you don't already have those things out, make sure you pause the video now so you can go get them and then come back. Remember, you can pause the video at any time. If you need to rewind the video and then pause to finish notes, that's perfectly fine. And then if you ever have anything like a question you need to ask, go ahead and email me or ask me during live time. Essential questions: what's theoretical probability? How do you find the theoretical probability involving a coin, die, and cards? Learning target: students will identify what theoretical probability is and find the theoretical probability in situations involving a coin, die, and cards. Make sure you're taking notes. Probability is a number between 0 and 1 that represents how likely an event is to occur. If the probability is 0, it's called impossible. If the probability is more than 0, greater than 0, but less than 1/2, if it's between those things, it's called unlikely. If your probability is 1/2, that's 5/10 or a 50% chance, that's called equally likely. If it's greater than 1/2 but less than 1, that's called likely. And if it's a probability of 1, that's a 100% chance, that's called certain. Theoretical probability: the probability of an event occurring based on examining all the possible outcomes. An outcome is a possible result of an experiment, and a sample space is the set of all possible outcomes that an experiment has. Let's talk about the notation. So this is the way it's going to be written. P stands for probability. A is your favorable outcome that you're focused on. Oh, my screen is going crazy. Favorable outcome. So whatever specific outcome you're wanting to have happen, that's what you're going to write in that parentheses. If it's like tails, you're going to write T. If it's heads, you're going to write H. If it's rolling a 3, you're going to put a 3. Whatever outcome you're more focused on, you need to write that in the parentheses. Theoretical probability, dealing with coins. What's the probability of flipping a coin and getting tails? So P for probability, and the favorable outcome we have that we're focused on is getting a tails. So the probability of getting tails, P parentheses T. In the numerator, you want your favorable outcomes. Well, you're only focused on one outcome, and that's getting tails. In the denominator, you're going to have your total number of outcomes possible in the sample space. So the possibilities are heads or tails. So there's 2 possible outcomes in your sample space. So your probability is 1/2, which is 50%. And that was called equally likely. Excuse my handwriting. So let's go ahead and try to work on our notation and solve a problem with it. So the probability, P, of rolling a 5, so let's put 5. So P parentheses 5 for probability of getting a 5. Again, you're focused on just getting a 5. That's only one outcome. But if you list out your possibilities, list out every outcome you have in your sample space, you could roll a 1, 2, 3, 4, 5, or 6. So there are 6 possible outcomes in your sample space. And if you remember, that is called unlikely because it's 1/6, that's less than 1/2, but greater than 0, so your odds are just unlikely. Okay, let's focus on the other one. What's the probability of rolling a 7? Well, this one should be very easy because on a dice, there are only the numbers 1 through 6. So what's the probability of rolling a 7? Well, that's 0. And that was called impossible. That's never going to happen. Okay, so that's actually a very quick one. It'd be 0, and your total number of outcomes are technically 6. But if you type that in a calculator, again, you're going to get 0. So if something is impossible and you know it, it's going to be 0 for the probability. Impossible. So let's focus on finding the theoretical probability in questions involving cards. What is the probability? Oh, excuse me, I wanted black. what is the probability of drawing a 3? Well, this has a big difference between drawing a 3 in a deck of cards and flipping a coin and getting tails. Because when you flip a coin, there's only one tails. In a deck of cards, there's 4 different 3s. So make sure you're listing out all of the outcomes in your sample space so that you can circle the ones that are your favorable outcomes. When you did a coin, we listed out heads or tails. And you realize there was only one way to get tails. And if it was a dice, it was 1, 2, 3, 4, 5, or 6. And again, there was only one way you were going to get the number that you wanted. But there's a big difference here, because there are 4 3 cards in a deck of cards. There's a 3 of hearts, a 3 of diamonds, a 3 of clubs, and a 3 of spades. So there are 4 3s in a deck of cards, and there are 52 cards total in a deck. If you type that into a calculator, you should get this decimal. And if you were to round, say to the nearest hundredth, you would have 8 hundredths. And again, this is between 0 and 1/2 as a probability, so this is called unlikely. Okay, let's focus on the other one. What's the probability of getting a card that's a diamond or a heart? So there are 13 cards in each suit. So there are 13 diamonds, and there are 13 hearts. Because we're focused on either getting a diamond or a heart. So those added together, you would have 26 favorable outcomes. And then how many outcomes are total here? Well, there are 52 cards in a deck of cards. So the probability of getting a diamond or heart, when you add those two outcome lists together, those two favorable outcomes added together would be 26 possibilities. And there are 52 total outcomes in your sample space. So 26 over 52, do 26 divided by 52, numerator divided by denominator, you get 5/10, which is 50%, or 1/2. And that's called equally likely. So you're just as equally likely to get a diamond and heart as you are to get a card that's not a diamond or a heart. Okay, let's go through a summary and reminders. Probability is a number between 0 and 1 that represents the likelihood of an event occurring. 0 means impossible. Greater than 0 but less than 1/2 is unlikely. 1/2 exactly is equally likely. Greater than 1/2 but less than 1 is likely. 1 is certain. Theoretical probability is the probability of an event occurring based on examining all the possible outcomes. An outcome is a possible result of an experiment. Sample space is the set of all the possible outcomes that an experiment has. Here's your notation on the right-hand side. P stands for probability. And then in parentheses, you're going to put the favorable outcome. So if you have like rolling a 3, you'd put 3. If you want to flip a heads, put H. Those are just a couple of examples. And you're going to put the number of favorable outcomes in the numerator and the total number of outcomes in the sample space in the denominator. And you're going to perform a division of those things once you have put them in. So you're going to do the numerator divided by the denominator, and it's going to tell you exactly what that decimal is. And you're going to be able to convert that to a percent because we've practiced that a lot. I hope you guys enjoyed this video, and if you have any other further questions, please email me or ask me during the live time.